Hello students, welcome to the class. In today's class, I will continue from the last lecture. So the question number 22 is, a particle of mass 10 to the power minus 3 kg and charge 5 microcoulomb is thrown at a speed of 20 meter per second against a uniform electric field of strength 2 into 10 to the power 5 Newton per coulomb. How much distance it will travel before coming to rest momentarily? It is given momentarily. Okay. See, if the electric field is directed from right to left and there is a positive charge here, there is positive charge here, Q plus Q, this electric field, then you know the charge plus Q will experience a force in a direction along the direction of electric field. So now, if this plus Q charge tries to go in this direction, then it will experience a force in this direction. And due to this, if it has some initial kinetic energy, because it has initial velocity 20 meter per second, so it will have some initial kinetic energy. Now if it tries to go in a direction opposite to the direction of the force, then it will, after some time, it will come to rest. Momentarily it will come to rest, right? It will go, and let's say it comes here after a distance s, after covering a distance s, let's say s, it comes to rest momentarily. From here to here, it comes to rest momentarily. When it will come to rest, then again this plus charge will come in the direction of the electric field, because at that position, its kinetic energy will become zero. All of its kinetic energy will be spent in doing some work against the force F, against the opposing force F, and at that position the force and the work done will be equal. The work done against the force will be equal to its initial kinetic energy, and it will cover distance s, and after that again it will start moving in the direction of electric field, because at that position its kinetic energy will become zero. There will be no kinetic energy, it will come to rest. Okay, so it's a fairly simple question. Then what does it mean? If it has to cover a distance s, then its initial kinetic energy, that is half mv square, should be equal to the work done against that force, right? That work done against that force is F into S, the work done, right? Then what will be half mv square? It will be force. You know, the force experience is nothing but the charge times the electric field. So Q into E times S. So from here I can write S equal to nothing but half m v square divided by QE, or the distance covered S equal to half times mass. What is mass? Mass is given 10 to the power minus 3. What is v square? It is 20 square. And Q is given to U 5 microcoulomb, 5 to 10 to the power minus 6, and E is 2 into 10 to the power 5. So it will be nothing but 10 to the power minus 3. If you open it, then it will be 400. 20 into 20 is 400, divided by 2, it will be 200, right? Then here 5 into 2 is 10, and 10 to the power minus 6 and 5 is 10 to the power minus 1. So 10 to the power 10 to the power minus 1 is 1, and it will be 0.2. It will be 0.2 meter. So before it coming to rest momentarily, it will cover a distance s, that is 0.2 meter inside the electric field, and after covering the distance 0.2 meter, it will come to rest, because now all of its initial kinetic energy has converted into the work it has to done against that force F. Okay. Okay, so let's move to the next question. Question number 23 is, determine the electric field produced by helium nucleus at a distance of 1 angstrom from it. So it is a very easy question. You know, in helium nucleus there are two protons. If there are two protons, then the helium nucleus will have charge Q equal to plus 2e, which is 2 into 1.6 10 to the power minus 19 coulomb. And if due to the charge Q, you have to find electric field at a distance 1 angstrom, then it is very easy. You know, electric field is 1 by 4 pi epsilon naught Q by R square. So it will be nothing but 1 by 4 pi epsilon naught, you know, 9 into 10 to the power 9, and Q is 2 into 1.6 10 to the power minus 19. The R square, R is 1 angstrom, 1 is 1 into 10 to the power minus 10 meter and square. You solve it, you will find the answer 2.88 10 to the power 11 Newton per coulomb. It's a very easy question. Okay, let's move to the next question. So the question number 24 is, two point charges plus q and plus 4q are separated by a distance 6a. Find the point on the line joining the two charges where the electric field is 0. Means if this is the line joining the charge plus q and plus 4q, then you have to find a point on this line where electric field will be 0. So where will be that point? It will be near to plus q. See, this plus q and plus 4q, if I want to find the electric field due to plus q and plus 4q, then this electric field due to plus q, if it is E1 and if it is E2, then at a particular position the strength of the electric field E1 and E2 will be equal and it will be opposite direction. That's why the E1 and E2 effect of E1 and E2 will nullify each other, and at a particular position the net electric field will be 0. Net electric field will be 0, and this point will be near to plus q. Because why it will be near to plus q? Because we know electric field is inversely proportional to the square of the distance and directly proportional to the charge. So जिसका चार्ज ज्यादा होगा इससे दूर होगा वो पॉइंट, जिस पॉइंट पे इलेक्ट्रिक फील्ड होगा 0, क्योंकि क्या है, इलेक्ट्रिक फील्ड इज प्रोपोर्शनल टू q एंड प्रोपोर्शनल टू 1 by r square. सो जो चार्ज का मैग्नीट्यूड ज्यादा होगा उस चार्ज से वो पॉइंट ज्यादा दूर होगा. अदरवाइज दिस q and r should balance, means the ratio of q by r square should be equal for E1 and E2. So the point will be far away from plus 4q charge and will be near to plus q charge, and at that position E1 and E2 will be equal, and let's say the position of this position from the plus q charge is x, and इस point से let's say ये distance है 6 से minus x. Okay, so E1 क्या होगा? E1 will be 1 by 4 pi epsilon naught the charge divided by the distance square x square, and E2 will be 1 by 4 pi epsilon naught charge कितना है 4q, distance कितना होगा 6a minus x. इस पॉइंट की बात कर रहा हूं मैं. Then it will cancel, q cancel, then it will be 1 by x whole square, it will be 2 by 6a minus x whole square, that is 1 by x equal to 2 by 6a minus x, or 6a minus x equal to 2x, और क्या होगा ये, it will be 3x equal to 6a और x equal to 2a. So जिस पॉइंट पे इलेक्ट्रिक फील्ड 0 होगा, नेट इलेक्ट्रिक फील्ड जिस पॉइंट पे 0 होगा, वो पॉइंट दिस प्लस q चार्ज से एट अ डिस्टेंस x पे होगा, मींस एट अ डिस्टेंस 2a. So it will be, the point will be near to this plus q charge, and this plus 4q charge से कितना दूर होगा, वो डिस्टेंस होगा 4a डिस्टेंस. Okay, that's it for today. Meet you in the next class.